because we usually, when we talk about biopolymers, we make this confusion between biopolymers and biodegradable. So here we can distinguish that there are two different definitions. From non-biodegradable bio-based polymers, we can give an example like biopolyethylene, biopolypropylene, and polyamide 11. So, as you may see in this slide, bio-based polymers can be whether biodegradable, In this slide, we are moving to talk about how to produce biodegradable polymers. The production can be executed through many processes. We mention here the most important ones, which are direct biosynthesis, which is made by microorganisms like bacteria, which is the case for polyhydroxylacanoate, or by plant producing cellulose and starch, or algae producing alginate. Polymerization of bio-based monomers we can use renewable resources like sugars, plant oil, to create monomers that are chemically or biologically polymerized into bio-based polymers such as PLA, biopolyethylene, and polyamides. For producing these biopolymers, we must think about their biodegradation, which could be launched by different conditions, other like aerobic or anaerobic composting, soil and marine enzymatic and hydrolytic. Since we have introduced the bio-based polymers, we move forward to presenting the link between them and bio-based composites. What are now bio-based composites? They are materials that combine a bio-based or renewable component with a matrix materials, often a biopolymer, to create a sustainable alternative to traditional composites. So, this bio-based component will play the role of a reinforcement to a matrix that is generally a bio-based polymer. These bio-based composites are present in the nature and could be whether natural fibers, this includes plant fibers like flax, hemp, jute, and bamboo, as well as animal fibers like wool and silk. And we have also natural fillers. The examples are wood flour, rice husk, ash, and agricultural waste, several agricultural wastes. Bio-based composite can be recognized based on several factors, but the most effective way is to classify them according to their main components. We can first recognize them regarding the reinforcement type. We can talk about natural fibers as flax, hemp, and jute, wood fibers, agricultural byproducts. We can also recognize them based on the matrix materials. We can have bio-based polymers, bio-based plastics, which are modified, polysaccharide-based materials, and amino acid-based materials. We can also classify them regarding the source of the bio-based component. We can have plant-based, animal-based, or microbial-based derivatives, And we can also have the hybrid composites, which combine two or more different types of bio-based composites. Are the bio-based composites all biodegradable? The biodegradability of bio-based composites depends on many factors. The biodegradability of both the matrix and the reinforcement, first, along with their biodegradability, components ratio plays an important role. The environmental condition, like marine conditions, soil, compost, some bio-based composites requires very specific conditions to be destroyed. Additives and processing conditions could whether inhibit the biodegradation rate or accelerate it. Nanotechnology proved to be more efficient where smaller particles proved to be more biodegradable than the micro ones. Now I'm moving to the major fields of application of these bio-based materials around the world. Before we mention the major fields, we must draw your attention that the business of bio-based polymers is estimated to be worth more than $6 billion. The statistics are from the recent one, from bizresearch.com. So this chart shows the global production capacities of bio-based polymers by region in 2022. Asia leads with 41% of the production, followed by Europe at 24%, North America at 90%, South America at 30%, Australia and Oceania contribute less than 1%. We can say that the dominance of Asia highlights its significant investment in bio-based polymer production, likely due to its growing industrial base and demand for sustainable materials. Europe and North America are also key players, reflecting their focus on innovation and sustainability initiatives. South America, notable share points to its strong agricultural resources important for biomass-derived materials. That chart illustrates the bio-based polymer usage across different market segments in 2022. We are using the same reference. As you may see, the largest share, 26%, is attributed to fibers, woven and non-woven one, followed closely by flexible packaging at 24%, highlighting the growing need for sustainable alternatives in these sectors. Rigid packaging accounts for 70%, while the automotive and transport industry makes up 30%. Building and construction claim 10%, showing significant interest in eco-friendly materials for infrastructure. Other sectors like agriculture, electronics, and functional application hold smaller shares, smaller parts. This breakdown reflects the versatility and increasing demand for bio-based polymers in diverse industries, as they are replacing more and more the traditional plastics. With all this application that has adopted to use of bio-based polymers and composites, we are asking ourselves, what are the future trends and innovation? Before estimating the trends and innovation, the real question is based, what is the greatest driver for bio-based polymers and composites adoption? The great drivers for bio-based polymers and composites adoption, the great drivers for bio-based polymers and composite adoption, we have, first of all, environment regulation, and this is due to government restriction due to reduce pollution and carbon emission. Scientific innovation, we take advances in different areas, are making these materials stronger, more versatile, and more affordable, which is essential for their mainstream adoption. Another important factor is customer demands. Since consumers today are more informed and concerned about environmental issues than ever before. They are looking for eco-friendly alternatives and are willing to support brands that adopt sustainable practices. Along with the sustainability and eco-friendly trends, merging renewable innovation with consumer demand for greener, long-lasting, and environmentally responsible materials. Now, we pass to mention the most important innovations in bio-based polymers, which are, the first one, advanced chemical modification. Researchers are actually developing new chemical treatments to enhance the properties of bio-based composites. Then we have also the hybrid composites, the combination of natural fibers with synthetic materials like glass or carbon fiber offers a balance between sustainability and high-performance materials. Finally, fully plant-derived composites. These materials use both bio-based fibers and resins, offering a completely renewable alternative to traditional petroleum-based composites. How about the future trends? We have an exponential market growth. The global bio-based composites market is projected to grow from 5.9 billion in 2023 to 9.0 billion in 2029, with a compound annual growth rate of 7.4%. We have now actually in the market smart composite. Emerging smart and reactive bio-based composites can respond to environmental change without external control. These materials are being developed to react to variations in temperature or light, opening up new possibilities in adaptive structures. And we have also advanced manufacturing techniques, innovation in manufacturing such as automated fiber placement and 3D printing with composites are set to transform production processes. These technologies allow for highly customized parts, reduce waste, and increase efficiency. And now we are arriving to the conclusion of this talk. The question is no longer if we can engineer tomorrow's materials sustainably, but how soon we can fully embrace nature blueprint in a world that demands both progress and environmental responsibility. Bio-based polymers and composites stand as the bridge to a smarter future. These materials are not just alternatives to traditional plastic, they are also living technologies inspired by nature and engineered to sustain life cycles, from creation to degradation. As we have seen in the previous slides, they offer a path where innovation meets sustainability, where high-performance materials come from renewable resources, and where waste transforms back into value. Materials not only biodegrade seamlessly, but also capture carbon, self-heal, and respond to their environment. This is the frontier where bio-based polymers and composites are hidden. The next leap in innovation will blend nanotechnology and biotechnology, creating self-repairing materials inspired by the human body and smart packaging that extends shelf life and by responding to temperature change. Even 3D printed biocomposites could be engineered for everything from lightweight airplane components to custom medical implants. And thank you for your attention. And once again, sorry for the problem that occurred. And probably I was then in a hurry reading. So if there are any questions, please don't hesitate. Thank you.
Thank you. Thank